we go. Essential question. How do you simplify rational expressions? Well, first of all, let me explain to you kind of what a rational expression is, just in general. A rational expression is, well, we know what expressions are. A variable expression is, if you just look at this one up here above my hand, that is a variable expression. Specifically, it's a polynomial. More specifically, it's a binomial. So that's an expression on the bottom here, underneath my hand, the denominator, if you will. That denominator is also a variable expression. In fact, it's more specifically a trinomial. Well, if you take expressions like that, or more simpler ones, it doesn't matter, like this over here, these two guys, they're just simple little binomials, whatever. But if you take those and make one a denominator, and one a numerator, making it a fraction, a rational expression is exactly what that looks like. Now this right here is a rational number. This is a rational expression. So anytime you have kind of a fraction bar, if you will, that's called a rational expression with expressions in it. So here's the topic though. We're going to take this rational expression, as ugly as it is, we're going to learn some things through this little video and throughout a couple of days of how to do some things to it to get it down to this particular simplified form. And you might be asking, what in the world? Well, watch. It's the same concept as taking 4/8 and doing some things that we already simply know how to do to it, the 4/8, and making it much more simpler, 1/2. Because you all know 4/8 is the same as 1/2. So we're just taking a process, a very simple one, to do that. We're going to do a process to get this bad boy simplified down to that. So that is the concept. Now there's 3 things you need to make sure that you're aware of, just to go back and recall. One is GCF, the second one is a difference of 2 squares, and the third one is just regular old factoring, trinomials. Well, back over to GCF, remember it's this. If you have an expression, you can factor out the GCF, whatever it is, in the expression, if there is one, and you rewrite it like this. So it's as if you're undistributing the GCF. And this stuff down here in blue is just a checks and balance for you to see, and for me to make sure I did it correctly. Because if I take this 2x and I distribute it back through the parentheses, I would get 4x squared, and I get 2x. And that's exactly what I started with here. So I did the proper undistribute, if you will, of the GCF. I factored out the GCF properly, because when I multiplied it back through, it came back to what I started with. So that's phenomenal. Over here, difference of 2 squares. Remember, we talked about this. A couple questions to ask yourself. First of all, 1, is it a binomial? Check. Is there a subtraction, meaning difference? Is there a subtraction symbol? Check number 2. The next thing you had to do is say, okay, if those 2 are true, which they are, then can I square root that first thing? In this case, I actually can. Check. 4th question, can I square root 36? Well, the square root of 36 is just a 6. So sweet. So I've check, 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 check. Check baby, 1, 2. Actually, now we're at 4. So you can check those things, and if that's the case, it satisfies the difference of 2 squares. Therefore, it factors into a particular pattern. So it's x minus 6, bam, and x plus 6. And again, in blue, I just used the full method to kind of multiply it back out so you see it works. So that's difference of 2 squares. Over here to the right, remember with factoring trinomials, man, we did this many different ways, but the way that we kind of grabbed a hold of in class was using our little makeshift Xbox method. You do it however you want. But since this is a trinomial where the a is just a 1, these are the easiest ones as we talked about. Remember, this is all you do. Draw your little Xbox, the a times c, the a, the coefficient here, and the c goes right there. The b term goes right here, and then you got to find 2 particular factors of -4 that multiply, if you will, to give you -4, but they have to add to give you a 3. Well, what's that? Well, that means I could do a 4 and a -1, because 4 times -1 gives me -4, and 4 plus -1 gives me a 3. Sweet. So then remember these, since again we're talking about a trinomial with a being a 1, these guys here are already your factors. So you take the 4 and put it in there, it's positive 4, -1 goes right here, so there is your factored form of this particular trinomial. So there's your 3 things you're going to absolutely use in this section and many to come. This whole unit, when we're talking about rational expressions, you're going to use these 3 things a lot. So let me give you this idea, this concept. You take a look at the second one. It is also another major concept that you got to understand. When you look at this chart here, you see a correct and an incorrect side. Well, the correct side is this. If you have AC, that is the same as A times C. I just rewrote it for you. And BC is very old. I know BC is way back in the day, and AC is very cold, but besides the point. BC is the same as B times C. Well, since these are factors, something times something, something times something, you can actually take this c on top, as you know, and the c on the bottom and really reduce them out, cross them off, because they just simplified to a 1 over a 1. So really it's just a and b on top. And this will be your final simplified answer, if you will, if you started with something like this. Likewise, if you had AC, brr, and CD, boo, CD, or you could just say, neat, what is CD? Musical CD, that is, whatever. So if you multiply this out, or I guess expand it, if you will, so you have A times C and C times D. Well, you can cross this guy off on top and this guy off on the bottom because they are factors that are the same, one on top, one on the bottom. So now you're just left with A times D. Sweet. Now I gave you a specific example down here written in black marker. You see 12/8. Well, I just kind of took the 12 and rewrote it into the two factors of 3 and 4. Now I know 2 and 6 would be 1 and 1 and 12 would be another possible factors of it, but I wrote 3 and 4 for a specific reason. Because 3 and 4 are factors, and 2 and 4 are factors of 8. But as soon as I have factors that are the same, one on top and one on bottom, I can cross those bad boys off. And I'd just be left with 3 halves. So you all know this too, because you can take 12/8 and divide the top by 4 and the bottom by 4, which would reduce it down to 3 halves. So this is simplified from 12/8. Simple thing as that. Well, that was weird. So let's go over here to the left, or actually it's my left, your right, whatever. Flip upside down and you'll see how it works. Whatever. So the incorrect side is this. This is something that happens a lot of times. It's a common mistake that all of us see with these types of questions when we're reducing things and crossing things off. If you have addition, not multiplication, if you have addition, I'm telling you right now, what you cannot do is this. You cannot take this C on top and this C on the bottom and say, sweet, I have a C on top, a C on the bottom, or I have a 2 on top, a 2 on the bottom, a 3 on top, 3 on the bottom, doesn't matter. You cannot do this. And just cancel them out, and just get AB. That is not an equivalent expression. Likewise, if there's subtraction, you cannot, not equivalent. You cannot just take the C's and say, sweet, they're gone, peace, and get AB. Can't do it. Now I gave you a specific example here, again written in black marker, to help you understand it. I just drew in some numbers. So if we say A is 2, and B is 3, and C is 10, and I put the 2 in here for A, I put the 3 in here for B, and I put the 10 in here for both C and C Music Factory. That goes way back. So there's that. Now I did it over here, so I put the 2 in again for A, so that's what that is, and the 10s and the 3. So if I add this together, what I'm actually going to get is 10 plus 2, which gives me 12, and 3 plus 10, which gives me 13. That is the actual answer. You would get 12/13 if you actually put the 2, 3, and 10 into this particular formula. Well, whatever. Expression. So here's the deal, though. What I'm telling you is, a lot of times people say, oh, I can just cross off these things and it equates to just AB. Well, look, if I did that, if I crossed off the 10s here, what that would mean is I would just be left with 2/3. Well, I just told you 2/3 is not correct. It is not the same expression. It's not equivalent. That's not what you do. You can't do it because of the addition, nor can you do it with subtraction. That is a major thing. You can only cross off things if there's certain factors, meaning multiplication, 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 things being multiplied. That's the only time that you can really cross things off. I hope you write that down because that is extremely important. Go back and listen to it again if you need to.